Okay, so this is the review you guys are supposed to be working on Monday the 18th. I will make the first 4 problems more explicit on your quiz day. Right now, I know that it's kind of hard to tell because we don't have any congruent angle or congruent marks for the sides, but we're able to see this first one is not going to be regular polygon, so it's not regular. And you see this because there are angles of different sizes, and you see, let's go here, I'll highlight. So you have angles of these different sizes. You can see where this one looks more acute and that one looks more obtuse, and then the sides are different lengths, so it's not going to be regular. Because remember, to be regular, it has to be congruent angles and congruent sides. For number 2, a question like this in your quiz will actually be where I have these marked. So that way you can see. And then they would also have these marked. You would see that we have congruent sides, and now as I'm drawing them in, congruent angles. Therefore, this is a regular polygon. And then over here, you can look at it and pretty much see that these are going to be right angles, congruent sides, and therefore, it's going to be a regular polygon. And over here, once again, you see 1, 2, 3, 4, 5, 6, 7. So we call this regular. So this one had 7 sides, so we call that a heptagon. Over here, this one had 1, 2, 3, 4, 5, 6, 7, 8 octagon. You know, over here, this is a regular quadrilateral, which we would call a square. Okay, so the next one is state whether these are convex or concave. So remember, with the convex and concave, you can, for it to be convex, you draw a line and it hits it exactly 2 places. For it to be concave, you can draw a line somewhere in the diagram or in the figure where it's going to hit more than 2 places. So we see here, you draw this line, it hits 1. See if I can get my pen to write. It hits 1, 2, 3, 4. So we know this is concave. Over here, once again, we can draw a line. It's going to hit it more than that many, more than 2 times. So you see 1, 2, 3, 4. Once again, this is concave. Number 5. So that only hits twice. Only hits twice. Only hits twice. Only hits twice. We see this is convex. Convex. And then over here, there are a couple ways to draw a line, so let's see if we can get one where it would hit that. You see that you have one goes through here. So my lines are struggling drawing through that part, so let's see if I can get it to go from the other side. Let's see here. You could draw this line. I'll highlight it in yellow. Well, that's a little heavy, so if we go back here, I'll make that. And you see that it also hits it. 1, 2, 3, 4. So it's concave. So that's the first page that you guys had to do. On this one, we're still doing the same group of questions. So decide if it's concave or convex. So can we draw a line that's going to hit it more than 2 times? So over here, you notice that only 2 times. We can draw this line where it hits it more. It hits it 1, 2, 3, 4. So we see this is concave. Over here, I'm going to draw it a few times, see if we can come up with anything that's going to hit more than twice. And we see no, there's nothing. So this is convex. Find the measure of one exterior angle in each polygon. Round your answer to the nearest tenth, if necessary. So for this first one, we see this is a regular polygon. So for the visual of it, I'm going to extend these exterior angles. Okay, so since this is a regular polygon, you can see it because the sides and the angles are congruent. You know that the exterior angles are all going to have the same measure. So I'm going to put X, since I don't know the measure of that angle, in each of these spots. So we want to find that value of X because we want to find the exterior angle. And we know that the sum of all the exterior angles add up to how much? Well, we know that they add up to 360 based on our theorem. So we have 1x plus 2x, x plus 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 x is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8x equals 360 degrees. We want to solve for x. So for us to do that, we are going to take 360 and divide by x. Or not divide by x, divide by 8. And x gives us 45 degrees. So you know that all of the exterior angles, since it's a regular polygon, will be the same. And they're all going to have to be 45 degrees. Because if you add them all up, they're going to have to equal that 360. So over here, let's count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, making sure I didn't miscount. Once again, just for the visual of it, I'm going to extend these exterior angles, if I can get them to draw right. We try it one more time. You can see without drawing these how many angles we have. We just counted that. But I think that this is a clearer way of viewing it. So we don't know how many, so we're going to put x in. X, 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 X. Once again, you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Makes sense because it can match the number of angles. So we have 11x equals the sum of the exterior angles. And we know that that's always going to equal 360 degrees. So it equals 360. So 360 divided by 11 is going to give you 32.7 degrees. Remember, it says round to the nearest tenth. That's 1 decimal place. Okay, this one says find the measure of one interior angle of each polygon. So to find the sum of the measure of interior angles, we have a specific formula. If you don't know that, you should go look it up now. Okay, so that formula is going to be n minus 2 times 180. So n stands for the number of sides. So we have 1, 2, 3, 4, 5, 6. So we have 6 minus 2 times 180. It's going to be 4 times 180. So when we do 4 times 180, you end up with 720 degrees. Over here, we have to count the sides again. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Double check my counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now you have 9 minus 2 times 180. That becomes 7 times 180. So what is 7 times 180? So 7 times 180 is 1,280 degrees. So as you see, what I just did not totally answer our question. So it says find the measure of one interior angle of each polygon. So we actually need to go back. I'm going to go do that in orange and fix this. So one interior angle. So if this is the total sum, is what we just found, to find one interior angle, we're going to have to take our number we have. So we have 720. And we have to divide it by the number of sides. So divide it by n. So it's going to be 720 divided by, and we know we have 6 sides here. So 6 goes into 7 one time, 6 goes into 12 two times, so 120 degrees, the sum of one angle. Let's go back here. So the measure of the angles. $120 degrees. We're going to do the same thing over here. We know both these are regular polygons, so therefore the angle measures have to be the same. So we know the total sum. So the sum is going to be that 1,280, and we're going to divide it by our 7. So 1,280 divided by 7. So let's pause. It should be 1,260. Double check my math there. I'll do it one more time. So 7 times 180. Yeah, it's 1,260 degrees. So sorry for that. And then we take the 1,260. We're going to divide by 7. So when we divide by 7, we end up with 180 degrees. Okay, we're not dividing by 7. I really apologize, guys. Okay, so we're dividing by the number of sides, which is 9. So 1,260 divided by 9 will give me 140. And to double check it, since I made 2 errors there, we're going to multiply that back by 9. And yes, it gets us to the same spot. Okay, so 140 degrees is the measure of the angle. Okay, now they want us to find the sum of the interior angle sum. Let's do that again. Find the interior angle sum for each polygon. Round the answer to the nearest tenth if necessary. So this is where we were just at. The first part we did in purple. That's what we're having to do now. So then we know to do this we have to count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you're going to have to do the n minus 2 times 180. So it's going to be 12 minus 2. Yes, that's a minus sign, times 180. That gives me 10 times 180. So remember, when you multiply by 10, that's just adding a 0 to the end. So I have 1,800 degrees. Now over here, we have 1, 2, 3, 4, 5, 6, 7. So you have 7 minus 2 times 180. That becomes 5 times 180. Take a second and get out your calculator. It's going to be 900. Again, sorry for number 14. Okay, so now we're at the find the area portion. So remember, we have the area of a square as the area equals the side squared, and we have a rectangle which is area is base times height. So here we can see this is going to be a square because we have the two sides that are the same. So you have area equals 6 kilometers squared. So the 6 times 6 is going to be 36. And then for the units, remember you have to do this. It's going to be km, and you put the square with it. So when you have an area, the units have to have the 2. Over here again, you see that you have area is going to be, they're the same measure, it's a square. 9.3 inches times 9.3 inches. Or you could write it as that 9.3 inches squared. We know that the inches are going to be squared, but then we have to calculate the first part. So get out your calculator again. 9.3 times 9.3 should give us 86.49. And I believe the directions on the last page told us to round to the nearest. Oh, it's on this one. So it just says find the area, so we don't have to round at all. This one works out perfect. So we just put this here. This one says find the missing measurement. Round your answer to the nearest tenth. So now it gives you the area. And it gives you one side, and you're looking for the missing one up here. So we know that we have area equals base times height. We aren't sure if this is going to be a rectangle because we don't know that side length. So we know our area is the 127.7 kilometers squared. And then over here we have our height of 11.3 kilometers times our base, which we don't know. So now that we're going backwards, our side length is just going to be the kilometers for its units. So we need to get b by itself. So we're going to divide over by 11.3 kilometers. Divide over by 11.3 kilometers. So once again, get out your calculator. $127.7 divided by 11.3. So we see that the other side length is going to be 11.3 kilometers. So it is indeed a square. Over here, we have the same situation. We need to find our missing height. So we have area equals base times height. You know your area is that 90.3 feet squared equals 9.5 feet times my height. So we're going to take our 90.3. We're going to divide it by 9.5. So we're going to divide here, 9.5 feet, 9.5 feet. And when we do that, we end up with 9.5 feet. So again, we're looking for a side length. So the side length is going to have feet and not feet squared. Area is the only thing that's going to be squared units. Now we want to find the area of each of these. You see now that the side lengths are different. So we know that this is going to be a rectangle. So area equals base times height. So area is going to equal 8 inches times 9 inches. So we have 8 times 9, which is going to be 72 inches squared. Over here, we will again have area equals base times height. So area equals 7.5 mi, so miles, times 10.6 miles. So we have 7.5 times 10.6. which gives us 79.5 miles squared. Okay. And then the last part of this one again is finding the missing measurement. So you have two parts, the area and either the height or the base. So we know it's going to be area equals base times height. There we go. So our area is 65.8 yards squared equals, we don't know our base stays, height is going to be the 9.4 yards. I want to divide by the 9.4 yards. So when you put that into your calculator, you have 65.8 divided by 9.4, which actually works out pretty nicely, and gives you 7. One of the yards cancels, so the numerator has 2 yards, the denominator has 1 yard, so you end up with 7 yards. And then over here, we have the same setup, so you have your area equals base times height. You have 18.3 kilometers squared equals base of 3 kilometers. And then times height. We're going to divide to the other side by 3 kilometers. You see that we're going to be left with kilometers because we're looking for a missing side. 3 goes into 18 6 times. 3 goes into 3 1 time. So we have 6.1 kilometers. That K looks a little rough. So let's try to make that look a little prettier. Here we go. Okay, and now we're finally on to the last page. So the first part here is we need to find the missing angle measure. So we need to know what the sum of the interior of this shape is. Our first step is to count how many sides. So you have 1, 2, 3, 4. So you have 4 sides. This is a quadrilateral. We know what the sum of the interior angles of a quadrilateral is. You should memorize this from our last section. But in case you don't, you go back to that formula, n minus 2 times 180. So you have 4 minus 2 times 180. That's 2 times 180. You got 360 degrees. So we know that the sum is going to be 360 degrees. So you have 360 equals. We have our missing angle measure, angle 1 up here. So we write that first, the measure of angle 1. We don't know what it is. Plus the 2 we have, 1, 1, 2, plus 1, 2, 5. And then you have to remember what this symbol means. I know some of you guys are still struggling a little bit. Remember that means it's a right angle. So with that being a right angles are 90 degrees. So we're going to add up this portion. So do that. So you have 1, 1, 2 plus 1, 2, 5 plus 90. Double check my math, but I got 327. Plus the measure of angle 1 equals 360. I'm going to do the rest of that math over here. So 360 degrees equals the measure of angle 1 plus 327. We're going to subtract 327 from both sides because we want to get the like terms together. End up with the measure of angle 1 equals 360 minus 27. So if you don't have a calculator, you can take one here, you bring it to the other side. So this becomes a 5, that becomes a 1. You have 3. 5 minus 2 is 3. 33 degrees is our answer. You have 33 degrees. Over here, we're going to solve number 26. We need to see how many sides. So 1, 2, 3, 4, 5. We've done problems with 5-sided, but we might not remember the exact number of the interior sum angles. So we have 5 minus 2 times 180 becomes 3 times 180. So we have 3 times 180. It's 540. So we have 540 degrees equals the measure of angle 1, it's the one we're looking for, right up top, plus 90 plus 140 plus 105 plus 110. Combine this portion, so you end up with 90 plus 140 plus 105 plus 110. And again, I ended up with 445. Double check my math there. And then we're going to bring down our measure of angle 1 equals 540. We want to get the measure of angle 1 by itself. We want to isolate it, so we're going to subtract the degree measure to the other side. So we know that the measure of angle 1 equals, you have 540 minus 445, which should give you 95 degrees. And then number 27, I know that I kind of have a lot of stuff going on here. I'll change my color once again to that purple, so you know we're doing this one in purple. We need to know the number of sides, so we have 1, 2, 3, 4, 5, 6. You have 6 minus 2 times 180. So it becomes 4 times 180. And we've done this before. So what's 4 times 180? You end up with 720 degrees. So you have 720 degrees equals the measure of angle 1, the one we're looking for right here, plus 106 plus 153 plus 194 plus 135 plus 144. We're going to add up this portion right here. So when we do that, you have 106 plus 153 plus 194 plus 135 plus 144. I'm going to guess that this number here is also a 4. So as I did this math, let me erase that so we can see it a little better. I see that this number is probably not a 194. I'm sorry, that's kind of hard to read. I think it's going to be 144 again. So let's change this one over here to a 144. So this becomes 144. And we'll do it again. So you have 106 plus 153 plus 144 plus 135 plus 144. Okay, that's better. So the last one we had is 194. It showed that it was going to be higher than 120, and we can't have a negative angle. So that means I just must have misread that. So if we switch this to the 144, and we added all those together, we end up with 720 degrees equals the measure of angle 1 plus 682 degrees. We're going to subtract the 682 from 720. The measure of angle 1 is going to be 38 degrees, and that is much better. Okay, I'll give you a second here before I erase it, and we continue on. So we're on to our last three. These deal with the exterior angles again. We know the sum of all the exterior angles has to be 100 or 360 degrees, so it has to be 360. So we know that the measure of angle 1 plus 77 plus 102 plus 126 is going to have to equal 360. I'm going to put it up here since I ran out of room on that side. We're going to add up this portion. So we know that 77 plus 102 plus 126 equals 305 degrees. Plus the measure of angle 1 equals 360. We're going to subtract 305. Subtract 305. Once again, you see that you can take the 1 over here. This becomes a 5. That becomes a 1. 10 minus 5 is 5. 5 minus 0 is 5. You end up at 55 degrees is the measure of angle 1. We're going to get started here as well. We want to do the measure of angle 1 equals 104 degrees plus 48 plus 81 plus 65 plus the measure of angle 1. Ooh. You saw the error of my ways too. So let's try this one more time. Okay. We know the sum of the exterior angles is 360 degrees, which is going to equal the measure of angle 1 plus 81 degrees plus 48 degrees plus 104 degrees plus 65 degrees. There we go. That's better. We're going to add up this portion. Take a second. So 81 plus 48 plus 104 plus 65 is 298 degrees plus the measure of angle 1 equals 360. Like terms together, subtract this to the other side. Once again, you can change this to a 5, becomes a 1. You have 2, borrow another, 62 degrees. Measure of angle 1 equals 62 degrees. And the last one is finding the area of a figure that has a missing portion. So we talked about this the other day, and I gave you a couple options. So your first option is to find the measure or the area of each of the segmented pieces, and then find the area of the missing and then add them together. Or you can find the area of the whole thing and subtract. So let's do them both methods. So I'm going to write method 1 over here. We have M1. So method 1 is the area of the entire thing. And then add it together. So we have area of 1, area 2, area 3. So the first area, area 1, is going to be my height times my base length. So we see this figure here. It's going to be 4 inches times 15 inches. And we'll do that math in a minute. I'll change my color so it becomes a little less going on. Let's go here. We have area 2. What we see in this portion, that this goes down 10 inches. So that's going to give this portion here to be 15 minus 10. So that's going to have to be 5 inches because the total height is 15. You're going down the 10. What's left over has to be that 5. So we have 5 inches for our height. I'll erase some of that so it doesn't look as confusing. So we end up with the 5 inches of our height, and then we need to figure out our width. Well, you know the total width here is 14, and then you know the two top parts here are 3 and 4. So the part that we don't have accounted for has to be the part that's not those two. So you're going to have 14 minus 3 minus 4. So this over here is going to be 14 minus 3 minus 4. Well, that's going to give us 7. This has to be 7. So area 2 equals 7 inches times 5 inches. And then once again, I will change the color. We see area 3 here, area 3. We have a width of the 3 inches, but we need to find the height. So you had 15 inches as our height of the total figure. To get to the second area, you went down 10. So we know that this space here is the same 5 from over here. And then we have to add on the additional 7. So you end up with 5 plus 7, which is going to be 12. So you have area 3 equals 12 inches. And you also have that width of 3 inches. So our first one, you have 15 times 4, which should be 60. So you ended up with 60 inches squared. Our second one is 7 times 5, and that's going to be 35 inches squared. And our last one is 12 times 3, and that's going to be 36 inches squared. So when we add all of these together to get the total area, I'm going to go right here. So area 1 total equals area 1 plus area 2 plus area 3. That gives you the 60 meters squared. Oh, we're in inches. I apologize. 60 inches squared plus 35 inches squared plus 36 inches squared. So when we add all these together, you end up with 60 plus 35 plus 36, 131 inches squared. So that's your first method. Okay, so that was the first method. Again, I'm going to clear it all so I can show you the second method. I know it gets a little messy. So let's go back and try this again. So I'm going to start with a little more space. We have method 2. We just have to put M2. Okay, and here you treat this as if this rectangle was a complete rectangle. So you have all of this. You're going to find the area of the total inside of all of it. So we treat that as our total area, which is going to be your length times your height. So base times height, which is 14 inches times 15 inches. Then you have to subtract the smaller portion that you have above that is not in part of the original figure. So we want to subtract the other two. So the way I'm going to do this, I'm going to form a rectangle right here. And I'm going to find this one and color this one green. So we have this shape here in green. And then we have this shape here and this brownish orange that we have to subtract. So our first step is to find the height of our first portion. So you know that it is this 10 inches. Here, it tells you it right here. But now we have to figure out the width. So we're back to the same spot we were in the first method, where you know that this portion is 3 inches. You know this portion is the 4 inches. So how much is left in the middle? So it's going to be 14 minus 3 minus 4, which gives you 7 inches for here. So we're going to call this area 1. And you see that area 1 equals 7 inches times 10 inches. Okay, next part, we are going to the other area. Go back to that orangey brown color. You see that your width, again, is that 3 inches. I'll write it above, makes it a little nicer. And then now we have to find the height. So how do we find this height here? Well, there we go. Okay, so how do we find that missing height? Well, you know you went down 10 inches. And then, so this portion, you went down 10. Now you're going back up 7. So this missing piece right here is going to be it's going to have to be 10 inches minus 7 inches. Which tells you it's going to be 3 inches. So you went down 10, you went back up 7, and now you're back at 3 inches. So you see you have a height of 3 inches and a width of 3 inches. So area 2 is going to be 3 inches times 3 inches. We know that's 9 inches squared, 70 inches squared. Now we have to do 14 times 15. So 14 times 15, 210. Subtract 70, subtract 9. So we have, in this method, you do your area total equal or minus area 1 minus area 2 equals the area of our figure. So that's going to be 210 minus 70 minus 9, which brings you that same number of 131 inches squared. So again, when we're talking about area, it always has to have the inches squared, or it has to have a squared unit.